we're going to develop the unit circle. Now, the last couple days, things have kind of been just a little random, but I needed to show you all of those so we can kind of try to put all of it together into one thing, which is what the unit circle is. You guys had to learn about the special right triangles and gain proficiency with it because that's what we're going to use to fill in our unit circle. You guys had to figure out how the sine, cosine, and tangent, cosecant, secant, and cotangent kind of how you can get those from a coordinate point on a coordinate graph because that's what we're going to use for the unit circle. And you had to talk about the reference angles so we can understand how we're going to fill in this entire unit circle by knowing just the first quadrant, which is where all the reference angles are located. So let's get started. Because you guys did the homework from yesterday, I asked you a question where I gave you the hypotenuse of one of a 30, 60, 90 triangle. So let's say this is the 30-degree angle, this is the 60-degree angle, and the smallest side, the one opposite the 30-degree angle, should be a 1/2. The side opposite the 60-degree angle should be a radical 3/2. Right? As long as you remember how to use the information from one side length from a 30, 60, 90 triangle to figure out the other ones, you can pause the video, go through and just double check my work. All right. So that's the 30-degree. Let's talk about the 45-degree, 45-90, aka the right isosceles triangle. When you solved, you should have gotten a radical 2/2 once you rationalize the denominator. And there's a reason why I'm doing it this way, which hopefully with the assignment I give you will help you understand a pattern, because the expectation is that these triangles, you are able to figure out each of those measurements, and you should know it by heart. And hopefully when you see the pattern, you'll be like, oh, that's not that bad. And then over here, the third triangle is exactly the same as the 30, 60, 90 triangle from before, but I changed the orientation. So we have a 60-degree down here. We have a 30-degree over here. This is where the 1/2 is because it's opposite the 30-degree angle. And this is where the radical 3/2 comes in because it's opposite the 60-degree angle. Okay? So if you notice, the only thing these triangles have in common is that they all have a hypotenuse length of 1. And there's a reason why they all have the hypotenuse length of 1. It's because in the unit circle, the radius, aka the unit, is 1 away. So if you notice, we have 1, 0, 0, 1, -1, 0, and 0, -1. So if you can imagine, I'm actually going to make this a little bigger right now so we can draw a little nicer. If I kind of zoom in on this unit circle that I drew, I'm going to try to fit in all the triangles that I had before, right? So if I start with my initial side down here, and I rotate 30 degrees, if you remember back, you had a little triangle, right? And you had a point. And that point had an x and a y value. Well, if this is a 30 degrees, I know that this dotted line would have to be 1/2. If I look at the adjacent side of this triangle, well, that's going to give me my x value, which according to my drawing was radical 3/2. And notice the hypotenuse is still length 1. We'll pick this up and talk about how the other triangles kind of fit in.